Hello. The topic for today is convert from rectangular to polar coordinates. Convert from rectangular to polar coordinates. In the video before to this one, before this video, we are going to work about the definition of the polar coordinate system. Remember, when you had to work with the rectangular coordinate system, you have the system. This is on the, let me move it back, sorry. On the left side, we have the rectangular coordinate system. In the right side, we have the polar coordinate system. In the rectangular coordinate system, let me get a point here, pen. You use x and y. You select the value of the x and you plug in using x and y, you plug in the coordinate system. But in the polar coordinate system, I use the radio r and the angle zeta. Okay, in another video I have in my channel, I explain and introduce the definition of polar coordinate system. But today I'm going to show you how to convert from the rectangular to polar coordinate system. To do this one, you need to remember using the value of the coordinate system using x and y, because we started from the coordinate system with the rectangular coordinate to the polar coordinate system. You need to remember that the radio using x and y, the radio is x squared plus y squared. And the zeta angle is the arcotangent, it's the inverse function of tangent, the y over x. We're going to do this with many examples. Example number 1, I have the point 3, 4. 3, 4, and when you plug in here is 3, 4 here, 3 and 4, and this is the coordinate of the point. This is the point. Now this is the coordinate of the point in 3, 4. Okay, now x is equal 3, y is equal 4, and you substitute to find the r squared. 3 squared is 9, 4 squared is 16, you add it is 25, and finding the square root to find the value of the r is 5. Now I find the value of the r here to write the point 34 in the polar coordinate system. To find the angle theta, I use the arcotangent. Using the calculator, the calculator TI-83 or any calculator that have the possibility to find the arcotangent functions, when you apply this using the calculator, the angle zeta is the tangent, it's the same now, you get it here. When you find this one is 53.13. 53.13 is the angle. Now, my point in the coordinate system is r is 5 and the angle is 53.13. Here you have the angle 53.13 because it's 45, 50 and approximately 53. And now we have to come from the center here, you count 5 units and now you get the point in the polar coordinate system. If you see in the rectangular coordinate system, the point is in the first quadrant, and in the polar coordinate system, you see the point 2 in the first quadrant. That's very important because you will see what happens with another example. Next example, the point now is example number 2, 2 and 2 square root 3. The value of the x. This is 2 here, 2 point something is here. This is the point in the rectangular coordinate system. Okay, and now here, that's the point when you plug in 2 and 2 square root 3. Now x is 2 and y is 2 square root 3, and you use the formula to find 2 squared is 4. Now 2 squared here is 4, and the square root when you get a square is 3, and 4 times 3 is 12. when you added 16, and the square root 16 is 4. Now R is 4. Find zeta, you do the same thing. This is y, remember, is y over x. Y is 2 square root 3, and x is 2. When you find this one, you simplify 2 and 2, you have a square root 3. Now when you use the calculator, you have 60 degrees. Now the tangent is square root 3 in 60 degrees. Expressed is pi over 3. Now, using the graph, pi over 3 is here. This is pi over 3. Now we have the angle. The angle from this to this one is pi over 3. This is the angle. And now R is 4. You count from this one. 1, 2, 3, 4. And you see again the point in polar coordinate system lie in the first quadrant. And in the rectangular coordinate system lie in the first quadrant too. Now, finally, this is my answer. 4 and a pi over 3. 4 and pi over 3, the point 2 square root 3 in the rectangular coordinate system is 4 and pi over 3 in the polar coordinate system. Another example. Example number 3. Now the point is 6, 0. Continue. 6 is 6, x is 6, y is 0. 6 squared is 36. Now r is 6. Now r here, the value of the r is 6. To find the angle is the tangent, negative, the same thing, arcotangent. The tangent is, when the tangent is 0, the tangent is 0 in 0 or pi. Remember this, the tangent is 0 and 0 or pi. But I'm coming back now to the rectangular system because we need to decide is the angle is 0 or is the angle is pi. What are you gonna do? Go back to here to the rectangular coordinate system. And when you go to rectangular coordinate system, the point 0, 6, 6, 0, I'm sorry, is here. This is the point 6, 0. Okay? Now, it's evident I cannot use the angle pi because if you use pi, had to be in this side. No? But no, it's in this another side because it's in the positive side. Now, the corresponding angle is 0, no pi. Now, finally, this is the angle 0, and you count 6 units, and this is my point in the polar coordinate system, 6, 0. If you use pi, this point is here. And this is a mistake because you see here in the rectangular coordinate system, the point lie in the positive side of the x-axis, not in the negative side. This is a negative and this is a positive. Now you need to decide when that's happened. Next example. Example number 4. The point is negative 7, 0. When you plug in the coordinate in the rectangular coordinate system is x is negative 7 and a y is 0. This is the point, okay? In rectangular coordinate system. We're going to find the r. The same situation. X is negative 7, y is 0, 49, and square root of 49 is 7. Now I find r is 7. Tangent, negative 1 is the inverse of the tangent, is arcotangent. The same situation, 0 and pi, but now it's different. Now the point in the rectangular coordinate system lie in the negative part of the x-axis. Now you get this, and this is this. Now what is the angle? Now in the exercise before is 0, but in this now the angle from this to here, this angle is pi. Now I'm gonna use 6 pi. In the exercise before, the point in the exercise before, the point lie here because in the exercise is 6 positive. But in this case, it's 7 negative, lie in the negative side. Now you need to use pi. Another example. Example number 5, 0, 5. 0, 5. Now x is 0. y is phi, the radius is phi, arcotangent of phi over 0. What happened with is undefined? Because you cannot divide by phi, it's undefined. Where the tangent is undefined? In pi over 2 or 3 pi over 2. Pi over 2 or 3 pi over 2. Okay? Now, if you see the rectangular coordinate system, the point lie in the positive side. Now, you see the angle between here to here is 90 degrees. Now, here is pi, and the pi over 2 is here. If you use 3 pi over 2, 3 pi over 2 is here. And the point had to be in this side. Now, what are you going to use? Pi over 2. Now, you get this, and the point is here. You see? The point had to be here, and the angle from here to here is pi over 2. And do not use 3 pi over 2, because 3 pi over 2 is here. And this is not my problem. My problem, the point is here. Now, the point is in this part. Now, the angle is pi over 2. 5 pi over 2.